Traditional battery
The grids
or
are
maintenance
flat
free or
metallic
low maintenance.
lattices that hold the plate
that's on
material
the
and conduct current. In a conventional battery, the grids are made of a combination of lead and antimony. In maintenance-free or low-maintenance designs, the antimony is reduced or eliminated and replaced by calcium, cadmium, or strontium. On a no-maintenance battery, antimony is eliminated altogether, and since no water is lost, the need for filler caps is eliminated. This allows for a battery that
Nah, I
is
should get
almost
make
completely
one
sealed.
and make put all them
The
jokes.
grids
That's
are
the thing, I
designed to
can't
hold the
upload this
active
shit, son.
material. They're
Because
known
it's
as
a
plates.
fucking Blackbird.
The plates vary
why.
in number depending on the
I
amperage
can't.
rating
I
of the
try.
battery.
Answer.
The plates are separated
I try to get
by
it,
an
man, but for some
insulating
reason I
material.
can't share shit on here. It's
Each
just
cell
fucking stupid.
consists of a number of positive and negative plates.
Because it's like it's not like a new. It's not a new tablet.
Heavy metal
Man, it's like
connectors called plate
when
strips.
tablet first dropped.
Plate assembly of the plates, separators, and straps.
It's like the first
All
generation
an element.
iPod type shit.
Each element fits into an opening in the battery case.
That's it.
The case may be made of hard
I'll be
rubber
trying
or
to. Man.
plastic.
I wanted to.
The
Couple
case is
times.
divided into 6 partitions that form the cells of the battery. The positive plate straps of one cell
Shit,
are
I'm
connected
trying
to the
to cuff
negative
my
straps of
sister-in-law,
another,
John. She got
thus
an actual
supplying a
iPad,
series
new
electrical
jump.
connection.
If I can get that, then I can do all that
The
shit.
positive end of the battery,
That shit is just
positive plates
recorded.
are connected by a lead strap to the external positive terminal, while at the negative terminal, the negative plates are similarly attached. The terminals themselves may be located on the top of the battery or on the side. Post or top-mounted terminals are commonly used on automotive batteries. The positive post will be larger than the negative post to prevent connecting the battery in reverse polarity. If the battery has side terminals, they are positioned in the side of the container, near the top. These terminals are threaded and require a special bolt to connect the cables. Polarity identification is by positive and negative symbols. Some specialty batteries, and those used in some imported vehicles, may use an L-shaped top-mounted terminal. The cover is heat sealed to the top of the battery. If the battery is of a conventional or low-maintenance design, the cover contains cell caps that also serve as vents. On a no-maintenance battery, the cover contains gas vents, generally one on each side. A battery must be vented because of the expansion and contraction of its materials during temperature changes. It's also necessary to vent the gases that result from charging. A built-in testing device called a hydrometer is also included in the construction of the cover. The battery's electrical energy is produced between the active materials of the metals when they are placed in a solution of sulfuric acid and water. This solution is called the electrolyte. The electrolyte is a solution of 36% acid and 64% water by weight. This electrolyte has a specific gravity of approximately 1.27, in between that of water at 1.0 and pure sulfuric acid at 1.835. When charged, the positive and negative battery plates each react with the sulfuric acid in a unique way. As the sulfuric acid reacts with the active material in the plates, a difference in electrical charge between the plates is created. When the battery discharges, the sulfuric acid solution weakens, and after a period of time, no further reaction takes place. But when current is applied to the battery, the reaction is reversed, and the sulfuric acid can be restored to its former strength. This is why an automotive battery is rechargeable. The battery converts incoming electrical energy back into chemical energy. Automotive batteries are sometimes called storage batteries. Energy is stored within the chemical makeup of the electrolyte and plates. The battery uses the creation of positive and negative ions to store and release electrical energy. Let's look at what ions are and the role they play inside a battery. Under normal conditions, the atom contains an equal amount of positive and negative electrical charges. It's possible to upset the balance of charges to create an atom that contains more electrons or fewer electrons. An atom with more electrons is a negative ion. An atom with fewer electrons is a positive ion. In a normal state, the electrolyte will tend to divide into positively charged hydrogen ions and negatively charged sulfate ions. These molecules, while electrically opposite, will match each other and produce no electrical activity. But if lead plates are placed in the electrolyte, the acid in the solution reacts with the lead in the plates. Electrons are pulled away from the positive or lead peroxide plates and move through the electrolyte to the negative or spongy lead plates. Over time, as the battery discharges, the reaction becomes weaker. More of the solution is converted into water, and lead sulfate forms on both positive and negative plates.
Did everybody hear
The
that?
ratio of water to acid will change.
Did everybody hear that?
No.
Over time, based on the battery's state of charge and rate of discharge, lead sulfates will accumulate on both plates.
So did that
It-
So that means
It
the cells will
slows
go
down the
back
reaction to voltage, and eventually
to charging.
your
and
battery will lose its
dispersing?
ability to hold a charge.
So is that for both charging and dispersing?
Yes.
So it will
It'll
disperse.
discharge. The battery won't hold a charge, so it'll discharge the system. And you create sulfates on either plate, depending on when you're discharging, when you're charging the battery. That's the reason that you can charge and discharge the battery so many times. They only last like 4 or 5 years.
Would that be when the battery actually swells up in a way?
Now,
From overcharge?
it's worse. If you overcharge your battery, that's worse. It allows more sulfates to accumulate on the plate.
That's even worse.
So it'll really cut the life down of your battery down by continually overcharging.
The way a car is, it won't ever overcharge a car battery, will it? Or can it?
It can depend. When we get into alternators, we'll show you. If the alternator malfunctions, it can
Overcharge it.
overcharge a battery. The alternator is really capable of putting out a lot.
Until in a discharged battery, the electrolyte is only approximately 17% sulfuric acid and 83% water. As the battery discharges, electrons leave the battery by the negative terminal. But in charging, the electrons are pulled away from the positive plates and forced back into the battery through the negative terminal. The force that does this is voltage. This charging and discharging process can occur many times. However, the battery does not last forever. As the battery discharges, the plate material expands slightly. On charging, the material contracts. This charging and discharging is called a cycle. Cycles tend to cause the plate material to loosen and flake away from the grid. Eventually, the battery plates crumble and the battery must be replaced. Batteries last longer if they're kept under charge. There are advantages and disadvantages to maintenance-free batteries. The maintenance-free battery tends to have a greater resistance to overcharging, a longer shelf life, and higher cold cranking ampere ratings.
Pause.
The disadvantages of the maintenance-free battery include a possible